Hello friends, my name is Sangeeta Joshi. My group and I will talk about quantum computing. We divide this topic in a four part, which are the background of quantum computing, essential of quantum computing, disruption by quantum computer, quantum enigma machine. Background of the quantum computing. So I'm gonna talk about this part. So first of all, what is the quantum computing? So a quantum computing is a machine designed to use the principle of quantum mechanics to do things which are fundamentally impossible for any computer which only use the classical physics. So now we know what's the quantum computing. So now what is the history of the quantum computing? So 1980, Yuri Manin proposed an idea of the quantum computing. 1981, Richard Feynman proposed a basic model for a quantum computer that could simulate quantum process. 1985, David Deutsch at the University of Oxford described the first universal quantum computer. At 1984, Peter Shor discovered an algorithm allows a quantum computer to factor large integers quickly. 1996, Lou Grover at Bell Lab invented the quantum database search algorithm. Grover's algorithm is a quantum search algorithm that runs very faster than any equivalent classical algorithm does. 1998, first experimental demonstration of the quantum algorithm. A working 2-qubit NMR quantum computer is used to solve the Reach problem. 2001, first execution of the Sol algorithm at the IBM's Alameda Research Center and the Stanford University. 2011, D-Wave claimed to have developed the quantum enabling and introduced their product called D-Wave 1. November 2017, IBM announced the availability of its most powerful 20-qubit commercial processor. In 2018, Google announced the creation of 72-qubit quantum chips called Bridgestone, achieving a new record. And also in 2018, Intel announced a new 49-qubit quantum chips.
Hi, this is Rakshita. Today we are going to talk about the essentials of quantum computing. Let's go through some of the quantum computing essentials. The quantum computing is based on the quantum mechanical phenomenon and which involves the superposition and entanglement. It is difficult to implement and break through because it involves both math and physics. So let's go through quantum computer. Quantum computer is a computer performing quantum computing. These computers are used in solving problems quickly than the conventional or standard computers. It uses the best quantum algorithms that computes faster than any other computer. These computers are designed for a specific task. Let's go through some of the basics of the quantum computer or computing. All common computers use zeros or ones for their computations, like ordinary or standard computers. The quantum computers use quantum bits or qubits, which are represented by zeros and ones at the same time, or the combination. These quantum computers are faster than some of the supercomputers as of now. These computations are made with very small number of quantum bits, and research is still going on. The significant point is that up for the qubits is, if you are going to perform with one single qubit, we have operations performed on 2 values. For 2 qubits, we have operations performed on 4 values. For 3 bits, its operations performed on 8 values. So on, we say for n bits, we have 2 power n values of operations performed at a time for a quantum computer. Hence, we achieve quantum parallelization, for which there can be multiple operations performed parallelly at the same time. Let's go through some of the key concepts of quantum computer. These quantum computer just have 6 common key concepts, which is superposition, entanglement, amplitude and phase, reversibility, measurement, and decoherence. The superposition. The superposition is superposed of zeros and ones, where we consider the physics here, and the entanglement is the superposition cannot be, or the zeros and ones cannot be separately defined, or it is merely impossible to define them independently. Amplitude and phase. Amplitude and phase is that it involves physics, where it talks about the wave and the light particles, where it involves the phase and the amplitude of a wave. The reversibility. A series of gates are used for quantum algorithm, which may follow in a reverse order, which is known as reversibility. Here, for measurement, we calculate the reverse order and uses this measurement as a key concept, and these concepts are involved in the or implemented in the quantum computer. Decoherence is the creeping of errors in the quantum states. This refers to the state of an isolated quantum system where the errors creeps in, or just it's a human error, or it's any a deliberate errors creeping in quantum states.
So my name is Jessica, and I'm going to talk about how far in the future the disruption might be. So first, I will talk about what kind of disruption actually is caused by quantum computer. So first things first, if the quantum computer falls to the wrong hands, especially hackers, it will become dangerous. And it also poses a significant risk to both asymmetric and symmetric key algorithms, which are our current encryptions. In addition to that, quantum computer can threaten our secure and authentic communication because they are better than current computers in terms of calculating or searching exhaustively all secret keys, allowing an eavesdropper to intercept the communication channel. So now let's compare the current computers versus the D-Wave 2000Q system, which is the fastest quantum computer available currently. So now, the fastest supercomputer that we have right now is the Summit supercomputer. It was just released last month by U.S. Department of Energy's Oak Ridge National Lab. It is of the speed of 200 petaflops or 200,000 teraflops. So it can calculate what 6.3 billion people can calculate for every second an entire year just for 1 second by this computer. So let's compare it to our own PC. The PC that we have right now can only do 3 billion operations per second. Even the supercomputer is so fast that our PC cannot keep up. Now let's look at the D-Wave 2000Q system, which is the new quantum computer that is available. So it is of 1097 qubits, and it has been researched to outperform the current supercomputers by 3600 times and our PCs by 100 million times. However, this D-Wave 2000Q system is not a fully functional computer yet, so it cannot work by itself. And the worst part of it is it has to stay under a very, very cold environment. Now we were looking into how cold is cold. So it is gonna stay in a room that has 180 times colder than interstellar space, which is 0.015 Kelvin. Our body temperature is of 310.15 Kelvin. So if we probably go to that room where they store this quantum computer, we'll probably die. So now let's see how far in the future will the quantum computer be available. So some people have predicted that it is going to be available by 2030, and other researchers actually say that it will probably arrive in the next decade or two.
Hello everyone, this is Jerry, and I'm going to present the last part, quantum enigma machine, which might be the solution to the disruption. First, let's have a look at what the first quantum enigma machine looks like. As we can see, the secret key and message will be sent from Alice to Bob. Meanwhile, there may exist Eve, who intercepts information between Alice and Bob. The technology in the quantum enigma machine is to hide information in photons, the particle of light. Most importantly, quantum key distribution can guarantee the secret key secure fundamentally. The following scenario shows how quantum key distribution works. First, let's start from Alice's perspective. She creates a random bit 0 or 1, and then randomly selects one of her two bases, rectilinear or diagonal. She then prepares a photon polarization state depending on the bit value and basis. For example, 0 is encoded in the rectilinear basis as a vertical polarization state, and in the diagonal basis as a 45-degree state. In the same way, 1 is encoded in the rectilinear basis as a horizontal polarization state, and in the diagonal basis as a 135-degree state. Based on that, Alice can create a table of secret key, then transmit each single photon to Bob. From Bob's perspective, as he does not know the basis that each photon was encrypted in, all he can do is to select a basis at random to measure each photon, either rectilinear or diagonal. Also, he needs to record the order of his measurement basis and measurement result. After Bob has measured all photons, he communicates with Alice on a public channel. Alice broadcasts the basis for each photon, and Bob compares each basis he used. They both discard the bits that Bob used a different basis, which is 50% on average, and leave the other 50% bits as a secret key. Alice now can send the actual encrypted message through a traditional channel, and Bob can use a quantum key to decrypt it. But what if Eve appears? To check out the existence of Eve, Alice and Bob can compare a subset of their secret key. When Eve chooses the same basis which Alice used, Bob's measurement will not be affected, so Alice and Bob cannot find the existence of Eve. However, Eve still has 50% chance to choose a basis which is different from those Alice used. In this case, different bases will change photons' polarization. After Eve sends the changed photon to Bob, Bob's measurement will be different from Alice's result. When many errors occurred during the comparison, Alice and Bob could find the existence of Eve and abandon the old key, then make another new key. Therefore, the quantum key can be absolutely secure theoretically. However, accomplishing quantum key distribution in the real world is not so easy. First, small disturbances can change photons' polarization. Second, scientists now only have been able to send quantum key over several hundred kilometers. Third, much of the Internet's infrastructures need to be built. Okay, let me make a conclusion for our presentation. Quantum computer is capable of doing the fastest operations, but it is not fully functional as of now. On the other hand, there is a way to have a secure communication by using the quantum key distribution. So, quantum computer can evolve the existing computers into a more efficient system. With that said, people are still researching further to obtain the fully functioning quantum computer. Thank you very much. The following are references.